Now in your previous class, we actually acquire the knowledge of G and the formula F equal to G m1 m2 by r square. What is G? G is the universal gravitational constant. Now taking the two masses, one is huge and another is small. Take an example of Earth. So Earth having mass which is very high compared to a small mass which is situated on the surface of the Earth having mass small m. Now this mass is capital M, which is the mass of the Earth, and this is the mass of the small ball, like your football or cricket ball is situated on the surface of the Earth having mass small m, which is very small compared to Earth mass. Now due to that Earth having a mass, that means the Earth should execute a force on that small m. So that force is nothing but the gravitational force. Now there is a distance between these two masses which is r. Why? We consider the distance from the center of the Earth. There is an important concept which is called center of mass of the body. A body is a huge, but the mass is actually concentrated at a particular point. If we consider Earth as a kind of sphere, then the mass is concentrated on the center of the sphere. So we say that the mass, total mass capital M, is centered at the center of mass which is situated at the center of the Earth. So the distance between two masses then is from that point to that point, and we take as r. That r is called the radius of the Earth, and that is value 6400 km if we consider this is Earth. If this is another planet, then r should be varied, but for a simple case it is r and having value 6400 km. Now this body having mass m is attracted by the Earth. So this body, due to the attraction of the Earth, that in this body there is an effective force acting on that particular body, and that force on the body whose mass is small m is called the weight of the body. So weight W is nothing but the attractional force of the Earth on the body having mass m, and due to that force acceleration is created if the body is free falling. Then the acceleration created due to the gravitational pull is called the acceleration due to gravity. Mind it, this acceleration is due to the attractional force of the Earth due to a free falling of the body. That's why this is called the acceleration due to gravity. So weight is nothing but m, mass. Whose mass? The mass of the small body, and g, which is called the acceleration due to gravity of the Earth. That is actually acceleration of gravity. It is nothing but acceleration due to gravity. So W is the weight of that body. So weight is defined as the amount of gravitational pull exerted by a particular body due to the Earth gravitational pull. Now W equal to mg, and the gravitational force F is written as Fgmm by r square. G is the universal gravitational constant, m is the mass of the Earth, that m is small m is the mass of that body, and r square is the intermediate distance between the two bodies. So these two forces equal because this is the gravitational force, and due to the gravitational force weight is generated. So mg is nothing but Gmm by r square. So if we cancel out g, that means small g equal to gm by r square. So this is the relation between the small g and capital G. That g is the acceleration due to gravity, and that g is the value of universal gravitational constant. If we put the values of g, m and r square, then after calculating this result we get g as 9.8 meter per second square. This is the value as well as unit of acceleration due to gravity. So the value of g is 9.8 meter per second square.